The Hyatt Regency Walkway Collapse. The Hyatt collapse in Kansas City, 1981, is one of the deadliest structural failures in U.S. history. At first glance, the hotel seemed perfectly safe, with its multiple suspended walkways crossing the atrium. But a small design change during construction turned it into a death trap. Originally, the walkways were to be supported by continuous rods from the ceiling. The contractor changed it to two separate rods for convenience, which doubled the load on the connections above the second-floor walkway. No one recalculated the stress, and the joints were unable to support the weight. On July 17th, during a crowded tea dance, the walkways above the lobby collapsed, crushing 114 people instantly and injuring over 200. The tragedy highlighted a terrifying truth. Engineering calculations must match the actual construction, and even a minor oversight in design can turn an ordinary building into a lethal trap. Station Nightclub Fire. The Station Fire in Rhode Island, 2003, is a horrifying example of how design choices can turn a fun night into a nightmare. The club's walls and ceiling were covered in highly flammable acoustic foam meant to reduce noise. When the band's pyrotechnics ignited the foam, the fire spread almost instantly, sending toxic smoke through the crowded club. Exits were poorly marked, narrow, and blocked by overcrowding, leaving patrons trapped. In just 6 minutes, 100 people were dead, and over 200 were injured. Investigations revealed that safety regulations were ignored and that the building materials themselves acted as fuel. The station fire shows a terrifying lesson. Designing for comfort or aesthetics without considering fire behavior can be fatal. London Grenfell Tower. The Grenfell Tower fire in London, 2017, is a stark reminder of how modern design can be deadly when safety is sacrificed for appearance. The 24-story residential building was recently renovated with aluminum composite cladding, chosen for its cheap cost and sleek look. However, this cladding was highly flammable and allowed the fire to spread vertically at alarming speed. Inside, smoke alarms and sprinkler systems were limited, and many residents were trapped. Within less than an hour, 72 people lost their lives. Investigations revealed that cost-cutting and ignoring fire safety regulations turned a standard renovation into a catastrophe. Grenfell proves that materials and design choices matter as much as structural integrity, and flashy appearances can hide lethal risks. Boeing 737 MAX MCOS system. The Boeing 737 MAX disasters exposed how modern software design can override human safety. The aircraft featured the MCOS system, designed to automatically push the nose down if sensors detected a stall. However, the system relied on a single angle of attack sensor, and there were no clear warnings for pilots when it malfunctioned. During two separate flights, Lion Air in 2018 and Ethiopian Airlines in 2019, the system repeatedly forced the planes into dives, despite pilots' attempts to regain control, killing a total of 346 people. Investigations revealed that Boeing rushed the design and failed to provide proper pilot training, prioritizing schedule over safety. The 737 MAX shows a terrifying truth. A design that removes human oversight can turn a routine flight into disaster. Titanic's watertight compartments. The Titanic's design was hailed as unsinkable, but its watertight compartments hid a deadly flaw. The ship had 16 compartments separated by bulkheads, meant to contain flooding if the hull was breached. However, the bulkheads did not extend all the way to the top deck, meaning that once water spilled over one compartment, it cascaded into the next, accelerating the sinking. When the Titanic struck an iceberg in 1912, 5 compartments flooded, exceeding the ship's design tolerance. More than 1,500 people died, despite advanced safety measures like lifeboats and wireless communication. The Titanic disaster shows that partial safety is a false promise, and even innovative designs can fail catastrophically when the details are overlooked. Love Parade Stampede, 2010. The Love Parade disaster in Duisburg, Germany, 2010, shows how poor crowd design can turn a festival into a death trap. The event drew hundreds of thousands of people, but the venue had only one narrow tunnel for entry and exit, creating a severe bottleneck. As the crowd pressed forward, panic set in, and people were crushed against walls and each other. Emergency exits were insufficient, and the sheer density made escape nearly impossible. In the chaos, 21 people died, and over 500 were injured. Investigators concluded that event organizers and city planners ignored basic crowd flow principles, showing that even temporary spaces can become lethal if human movement isn't properly designed. Hillsborough Stadium Disaster. The Hillsborough disaster in Sheffield, England, 1989, is a tragic example of how stadium design can amplify human risk. The stadium had poorly designed barriers and limited exit routes, which trapped fans in overcrowded pens. On the day of the match, too many people were let into the central pens, creating extreme crowd pressure. As fans were crushed against fences, 97 people lost their lives, and hundreds were injured. Investigations revealed that the stadium's layout did not allow for emergency release of the crowd, and police mismanagement worsened the situation. Hillsborough shows that even entertainment venues can become lethal if designers ignore the basic principles of human flow and crowd safety. Chernobyl reactor design. The Chernobyl disaster is a grim example of how inherent design flaws can trigger mass death. The RBMK reactor had a positive void coefficient, meaning that as water boiled into steam, the reactor became more reactive instead of less, making it unstable at low power. On April 26, 1986, operators attempted a safety test, but a combination of design flaws and procedural errors caused the reactor to explode, releasing massive amounts of radioactive material. Hundreds of immediate deaths occurred, and thousands more suffered long-term radiation effects. Investigations revealed that the reactor design did not account for critical safety scenarios, and operators were unaware of the danger. Chernobyl shows that engineering choices in complex systems can magnify small errors into catastrophic events. Fukushima backup generator placement, 2011. The Fukushima nuclear disaster highlights how poor design choices can turn a natural event into a man-made catastrophe. The plant's backup generators, crucial for cooling reactors after a shutdown, were placed in flood-prone basements. When a massive tsunami struck on March 11, 2011, the generators were instantly disabled, cutting power to the cooling systems. Without cooling, 3 reactors overheated and melted down, releasing radioactive material into the environment. Hundreds of workers and nearby residents were exposed to danger, and massive evacuations were required. Investigations concluded that critical safety systems were poorly located, ignoring worst-case environmental scenarios. Fukushima proves that even redundant safety designs fail if placement and real-world risks aren't considered. Sampoong Department Store collapse, 1995. The Sampoong Department Store in Seoul, South Korea, collapsed due to reckless structural modifications and poor design choices. Originally designed as a residential building, the structure was converted into a department store, and heavy air conditioning units were installed on the roof without proper reinforcement. Cracks appeared in the concrete, but warnings were ignored. On June 29, 1995, the building gave way, killing 502 people and injuring more than 900. Investigators found that cost-cutting and ignorance of load-bearing limits turned an ordinary building into a deadly trap. Sampoong shows that ignoring original design intent and overloading structures can be catastrophic.